Hi guys, Mr. Bennett here and welcome to the first video lecture for the year. I want to go through a little bit of revision from Year 11 and the first topic we're going to be doing is a bit of modelling of data. So if we start looking at the models that we need to consider, the first model is a linear model in the form of y equals mx plus c or mt plus c, so you need to be adaptable with that in terms of looking at those things. Now remember the exponential model. So that's presented in the form of a e to the bt, but easily could be a times by b to the power of t as well. Just remember e to the power of b is in fact what we last year looked at as the b value. And remembering that obviously if it's a growth function that the b value had to be greater than 1, and if it was between 0 and 1 it was a decay function. So that would be considering that one there. Other models that we consider would be the power model, right? So looking at growth or decay type function there, and then we'll also look at the logarithmic model in that particular form there, and we will probably see some simple rational functions, but we're not going to really consider that as a possible model while we're looking at stuff. And then you can look at the quartic model or a cubic model. So depending on what your data looks like, just remembering that one there, that the model has a vertice point, so it turns. So you need to consider your data as, is it appropriate to extrapolate that long term, knowing it will turn. Alright, so the sort of steps that we'll go through is you get given two sets of data. We need to certainly obtain a scatterplot next. Obviously independent variable goes on the horizontal axis or the x-axis. And then we use our r-squared value to try and find the best match for our data, and then we'll choose the model based on that. So let's look at an example. We'll do the first one from the textbook's exercise 2a. So we're looking at the value of a coin going up over 40 years. Right, so you've got the value there in 1962, and then it's the value of that in 2002. So the first step, obviously, these questions sort of takes you through the things, what you've got to do. So the first step is to draw your scatter plot. So the first thing you need to do is go to your graphics calculator. And remembering going to start, if you go into edit, now I've already deleted the values in there, but if you you had values in your thing, remember to go up there and go clear, and that will delete everything in that column. I've actually entered all the values. Now 1962 I said is 0, and then obviously 1968 is 6 years after that. So I've put all those values into your calculator. So they're there in list number 1, list number 2. The next step is to go to your stat plot, and we'll turn that on. Right, and we're going to look for a scatter plot. So you come down and select the scatter graph, and then you select list number 1, list number 2. Right, we'll quit out of there. And remember the next step is to go zoom 9. Zoom 9 will give us a nice graph there, looking at the sort of function. So clearly it's not a linear function, is it? Alright, so you can say that's definitely not a possible model. It could be a quadratic, it could be an exponential or logarithmic, or possibly a power model. So if we go to our stat, the next thing we've got to do is to find our r-squared values. Alright, so if I want to list down these things, it's pretty pointless doing this first one there. But it's just a matter of going through each of these and going calculate. So I could put my r-squared value for linear as 0.7812. Right, so I go over here and simply, I won't worry about drawing the model because I think you can do that, and we'll do that in class. The first step obviously is to write down what your r-squared models are. So r-squared for linear, r-squared is equal to 0.7812, I think it was. Right. So then we go to the next one. Start. It's pretty quick to do this. We're going to do a quadratic. Number 5, right, keeping everything the same. Now, hopefully you've got the same new operating system. So my r-squared value there is 0.9732. So do that. So r squared is equal to 0.9732, and that's for our quadratic. And then we might go to our power model next, and then we might go to our exponential, and then our logarithmic one. Right, so they're the models that we'll be looking at doing this for. So quickly going through those. So stat, across to calc, quickly go up there and we'll do our exponential as 0. Right, so scroll down there. And that's 0.9988. So I can write that down. That's equal to 0.9988. I'll go to our power model. So again, stat, go across to calc. Power model is A. Might as well just scroll up there, it's quicker. And enter. Oh, it doesn't like the fact that we've got a 0 in there. I can tell you it's not the power model anyway. If you want to get a value, take the 0 out of there. Let's do the logarithmic one though. And that's number 9. And we come down to there. And that doesn't like that one either. I think you have to get rid of the 0 again. Right, but let's just imagine that we've gone through the process, and clearly the one that we want to choose is our exponential model. Alright, so if I go back to that model, if you're looking at part B, it says find the model V in terms of X that best fits. Okay, so that's what we'll need to do. We'll need to actually go use that model. So if I go to my stat button again, go across to calc, and go 0 up to exponential. I want to store this one in my y value. So if I go to vars function y1, and that will actually store that in my function, but it gives me my particular thing over here in terms of my exponential model anyway, doesn't it? So I can say that's equal to 124.46 times by b to the value, which is 1.1127, and that's to the power of t, or x in this particular case. So if I was actually going to write my model down, my model for this that I need to write down, because my y value, so my y value is v, that's equal to 124.46 1.1127 to the power of x, okay, because we're looking at x as x years. All right, so that's my value there. When I go to graph that on my calculator, I actually draw the line through there by doing your y1. Alright, so now I'm in a situation where I can answer the other questions. Alright, so if I go back to my questions there, estimate the auction value in 1930, penny value for that. So this is part C. So this is my V in 1930. So 1930 is how many years after 1962? That's going to be 8 years. So V of 8. That's going to be equal to 124.46. What's going on there? 1.1126. Was it 26 or 27? 27 to the power of 8. Now, the quickest way of doing this on your calculator is to then go into calc, put the value of 8 in there, number 1, and put the value of 8. And that actually works it out for you. And it's going to be 292.41. So you've got to go obviously to the nearest decimal place, 2 decimal places, 292.41 cents. Now, the next question obviously asked me to work out the average annual percentage increase of the thing over there. Now, it's using a compound interest formula, isn't it? Right, because it's growing exponentially. So what I need to do there is I need to go to my calculator, and I'd have to go to my finance, TVM solver. So I'd need to put in, it's over 40 years. I need to go and put my present value as 120. I need to put my future value. Now, remember here, you need to put this as minus. So 8, what was it, 763. And that's one payment per year. So then if I go up to work out my interest rate, alpha, it will actually tell me what my value is. So it's 11.3%. Right? Yeah, only expected to use your calculator for this. So part D, the average increase is 11.3%, which is quite a good return on any investment. So if you've got that over 40 years, you'd be very happy. Assuming the trend continues, what estimated auction value for that in the year 2025? So 2025 would be how many years? So that's 63 years, isn't it? Right, so if we go to do our thing on the calculator, so E, so after 63 years, right, then that's going to be 124.46, 1.1127 to the power of 63. Now you don't actually have to write this out because it's, assuming you've got a calculator, you know, probably don't need to write that out. So if I go to my graph again and then go to my calc and then I go value 63, enter, oh, it doesn't work. Now the reason it doesn't work is if we go to our window, it only goes up to 44. So if I expand my window to say 70, I might need to increase that to put in a 5 there or something like that, and then go graph. It's not going to be big enough anyway, but it still should allow me to work out what I need to do. So if I now go to my calc and go to number 1, which is the value, and put 63 in there, it should tell me what the value is. So the value is going to be 103,838.71. So that's going to be 103,808.71, and so that's what it's going to grow to in the year 2025. So the key questions there is really just working through on your calculator. Alright, so going through in your calculator and answering your questions, and like I said, this is a review of what we did in year 11. Now, just a couple of hints when you're drawing your scatter plot. Obviously, without doing it, you need to have your axes nice and straight there. Right, you need to label your axes, that's in years. Right, you need to label your vertical axis, that's the value in dollars. And then you have to have a regular scale. Alright, so when it says draw, we have to actually draw it accurately. If it says sketch, then you just have to sketch what it would look like. So if I was doing a sketch, I'd be doing values like, and I can show my line of best fit going through there, and then I'd have a rough estimate, that might be 100,000. 100,000, and that would be say 40 years. Okay, so that would be a sketch, but if you're looking at what we call a draw, to draw this thing, you need to actually draw that accurately. Now if you go to see what they've done here on the answers, then that's actually what we would be expecting, a nice regular scale. So good luck with those questions. I'd like you to have a go at all of as many of those questions out of 2A. And that certainly should give you a bit of revision of what we did last year. So good luck with those. Catch me in class if you need some help.